Welcome back guys to our channel. In today's video, we are going to solve some good problems from the chapter of functions from Sameer Bansal calculus book. Okay. In this video, I have picked some questions from exercise 1 and exercise 2 of this book. So we are going to solve single correct questions, top problems from single correct questions and paragraph type single choice questions. Okay. So I am maintaining a separate Google Drive link for this question PDFs of these sessions. You can get access to the question PDF by clicking in the link given in the description. Okay. And we are also using these markings that SCQ denotes single choice questions and PARA-SCQ denotes paragraph type single choice questions. Okay. The same markings I have used in the question PDF also. Let's start. So the first question is here. Let f defined from D to R be defined as fx equal to x square plus 2x plus a divided by x square plus 4x plus 3a, where D and R denote the domain of f and the set of all real numbers respectively. Okay. If f is a surjective mapping, then the range of a is equal to what? Okay. So we are told that f is surjective, right? That means this codomain of f should be equal to its range. So our codomain is what? Codomain is the set of all real numbers, right? That means y should take all real values, where y is fx, right? We are denoting this fx by y. So y should take all real values. That means if we denote this fx by y equal to x square plus 2x plus a divided by x square plus 4x plus 3a, right? That means if we try to express this in terms of a quadratic expression in x, we get this becomes y x square plus 4xy plus 3ay equal to x square plus 2x plus a, right? So we get y minus 1 times x square plus x times 4y minus 2 plus 3ay minus a, right? This is equal to 0. Now for each value of y, we should get some real x value, right? So that means this quadratic equation must have real roots, right? So the discriminant is greater than equal to 0. So we get 4y minus 2 whole square should be greater than equal to 4 times y minus 1 times a we can take common. So this becomes 3y minus 1, right? So we can cancel this 4 here. So this becomes 2y minus 1 whole square, which is 4y square minus 4y plus 1. It is greater than equal to, this will be a times 3y square minus then y minus 3y, so minus 4y plus 1, right? So we get from this inequality that 3a minus 4 times y square, then minus 4 times a minus 1 y, then plus a minus 1, right? This is negative or equal to 0, right? Now tell me, if we have this quadratic expression in y and it is always less than equal to 0, that means the graph should look like something like this, right? Like this, or it may be like this, right? So in this case, we have two conditions. We have the leading coefficient of this quadratic expression in y should be less than 0, right? So the leading coefficient is less than 0, as well as we have the discriminant of this quadratic expression must be less than equal to 0. So d less than equal to 0. So we have to satisfy these two simultaneous conditions, right? So we get from the first condition, a should be less than 4 by 3, right? This is our inequality number 1. And this, if we solve, d less than equal to 0 means 4 times a minus 1 whole square should be less than equal to 4 times a minus 1 times 3a minus 4, right? So we can solve this. It becomes a minus 1, then a minus 1 minus 3a plus 4. This is negative or equal to 0. That means a minus 1 times this becomes minus 2a plus 3. Sorry, I think here it will be 16, right? So this will be 4 multiplied with this, so this becomes a minus 1 times 4a minus 4. So this becomes a, so it is less than equal to 0. That means what? If we try to plot the wavy curve here, plus minus plus, right? So a must belong to the closed interval 0 to 1. Now we have a very interesting case here, that if I, let's say, take the case y equal to 1, what will happen? If y is equal to 1, that means this equation will be a linear equation, right? This will not be a quadratic equation. So we must get a single value of x, right? So we must have, in this case, if we try to put y equal to 1, we get 2x plus, this becomes a times 3 into 1 minus 1, so 2a equal to 0, right? That means x equal to minus a. So if y equal to 1, this is the only solution for x, right? Now we have to also satisfy the domain, right? Because let's say if this point x equal to minus a is not an interior point of the domain, then how can we get y equal to 1, right? So if we don't get y equal to 1, the range of the function will exclude the point y equal to 1, right? So the range will not be equal to the codomain, which is equal to all real numbers, right? So if we want to include y equal to 1 in our range, we must have this point x equal to minus a in our domain, right? Now if we check the domain of this function, what is the domain of this function? This denominator is non-zero, right? This is non-zero. So we must have the condition, this if we satisfy x equal to minus a, this becomes minus a whole square, so a square, right? Minus 4a plus 3a, it is non-zero, it should be non-zero, right? For domain to include x equal to minus a, we must have this condition. So a square minus a should not be 0, right? That means a should not be 0 or 1. So if we take the intersection of these two conditions here, condition number 1 and condition number 2 here, we get 1 intersection 2 as a must belong to the open interval 0 to 1. Okay, so this will be our answer. So what will be our correct option here? Option D will be correct, right? Okay, the next question is saying if x equal to pi times this function, then the range of the function y equal to sine of 2fx is what? Okay, so let us try to find the range of this fx function first, right? If we can find the range of fx, we can get the range of sine 2fx. Okay, so to find the range of fx, we get fx equal to pi times this square root x plus 7 minus 4 divided by x minus 9. Now if we try to check the domain of this function, we get x should be greater than equal to minus 7, right? And x not equal to 9. But for x equal to 9, if we check, we get the numerator and denominator both become 0 at x equal to 9, right? That means the limit may exist at x equal to 9, but the functional value does not exist. Okay, so if we check the limit at x equal to 9, limit extending to 9, fx becomes pi times this becomes 0, this becomes 0, right? So this is 0 by 0 form. If we try to rationalize, we get x plus 7 minus 16, so this becomes x minus 9, right? X minus 9 gets cancelled, so we get limit x tending to 9 pi times this thing 1 divided by under root x plus 7 plus 4, right? So this becomes pi divided by 4, sorry, this will be 8, so pi by 8 we get, right? Now if we try to check the nature of this function, whether it is increasing or decreasing, or it has a minima or maxima, local maxima or minima, etc. Okay, so we have to calculate the derivative of this function f dash x. F dash x is pi outside then we get x minus 9 whole square, then x minus 9 times 1 by 2 root under x plus 7 minus under root x plus 7 minus 4 times x minus 9 derivative will be 1. So this becomes this, and if we simplify, this becomes x minus 9 whole square, then it's under root x plus 7, and inside this bracket it becomes, so we can take this 2 outside. Okay, so this becomes x minus 9 minus 2 times x plus 7, so that is 2x plus 14, so minus 2x minus 14. This becomes plus 8 times under root x plus 7, right? So this becomes pi divided by 2 x minus 9 whole square under root x plus 7. Now this thing, if we check, this becomes 8 times under root x plus 7 minus x minus 23. Now if we look carefully into this expression here, we can see this is a perfect square. How? If we take out this minus sign here, we get minus outside, then pi times this thing outside, then we get x plus 23 minus 8 times x plus 7 under root. Okay, now we try to express this in form of 2ab. Okay, so this becomes 2 times 4 times under root x plus 7, and this thing will become simply a square plus b square. You can check, this becomes under root x plus 7, this whole square plus 4 square, right? So this becomes x plus 7 plus 16, that is x plus 23, right? And this thing 2ab is here with negative sign. That means what? We get this derivative is equal to minus pi divided by this thing times under root x plus 7 minus 4 whole square. Okay, now see this thing here, 2 times this whole square times square root, this is always positive, right? And this thing will be also positive, right? This is whole square, but here is a negative term, negative sign. That means this derivative will be always negative, right? So we have this derivative negative, means the function is always decreasing. So the function is decreasing, that means what will be its domain? Its domain is minus 7 to infinity, excluding the point x equal to 9, right? So if we check the value at minus 7, this will be the maximum value of f, and at x tending to infinity, the functional value will be the minimum value of f, right? So this f of minus 7, this becomes f of minus 7, if we check, 0 minus 4 divided by minus 7 minus 9, which is 4 divided by 16, so 1 by 4 times pi, right? So pi by 4, and at x tending to infinity, we get f is tending to 0, right? Because the numerator is a square root function and the denominator is a linear function. So we know the growth rate of a linear function is always greater, right? It will grow more rapidly. So in this case, the functional value will tend towards 0, right? But remember, it will tend towards 0. It will not be exact 0. Okay. So we must have the functional value f belonging to the interval pi by 4, sorry, 0 to pi by 4, closed at pi by 4, open at 0, excluding the point pi by 8, right? So we get f belonging to this range. That means 2f will belong to what? 2f will belong to the range open 0 to pi by 2, closed, except the point pi by 4, right? So we must have sine of 2fx, this belonging to the interval, this becomes 0, this becomes 1, except the value at x equal to or we can say 2fx equal to pi by 4. Okay, so at this point this value becomes 1 by root 2. So what will be our correct option here? Correct option will be open 0 to 1 by root 2 union open 1 by root 2 to closed 1. Okay, so option C will be our correct option. I hope you understood how we calculated the derivative and then analyze the behavior of this function. Okay, let's proceed with the next problem. Here it is saying the sum of all possible values of n, where n is belonging to n, okay, x is positive and 10 less than n less than equal to 100, such that the equation this greatest integer 2x square plus x minus n equal to 0 has a solution. Okay, so we have the equation this plus x minus n equal to 0, right? Now observe a very interesting thing in this equation, that if we take a look at this term here, this is an integer, right? No matter what x we feed into this function, this value what this function is returning to us, the value will always be an integer, right? So this thing is an integer, this n is an integer, n is belonging to n, right? This 0 is an integer, so x also must be some integer, because we cannot have this situation. Let's say we sum two integer 5 plus 2 and then we add some fraction, let's say 0.3 with this, and we are, let's say, getting some integer, let's say 6. We cannot have this situation, right? This will become integer, 5 plus 2 is an integer, but this is a fraction. So if all the remaining terms are integer, this term should also be some integer to get the answer as some integer, right? So we must have x as some integer. So let's take x equal to, let's take k here, k is some integer. Okay, and as x is positive, we have to start k from k equal to 1, right? So this becomes, this equation becomes 2x square. So 2x square is what? 2k square, right? If k is an integer, k square will also be an integer, and 2k square will also be an integer, right? So that means this greatest integer will be omitted. Okay, so this becomes 2k square plus k minus n equal to 0. That means what? N equal to 2k square plus k, right? Now we have to check the values of k. Okay, so if we try to check the values of k, this k will take only positive integer values, right? Positive integer values starting from k equal to 1. Now this thing is a quadratic expression in k, right? And this is increasing. We can verify. If we take, let's say, g of k as 2k square plus k, that means g dash k is 4k plus 1, right? This is positive for all positive integers k, right? That means the function is increasing, g of k is increasing. So if we try to put the values k equal to 1, we get n equal to what? N equal to 3, right? This is not possible because we are starting n from 11, right? 10 less than n less than equal to 100 means 11 less than equal to n less than equal to 100. So we cannot take this value. So let us take k equal to 2. 2 gives us 2 square. So 4 times 2, 8 plus 2. So n equal to 10. This is not also possible, right? Because we are not including n equal to 10. So we must have k equal to 3, right? For k equal to 3, we have 9 into 2, that is 18 plus 3. So n equal to 21. Okay, this value is acceptable. Then if we try to check this, n must be less than equal to 100, right? That means what is the maximum value we can put here in place of k? Maybe we can try, let's say, k equal to 5. So this becomes 25 times 2, so 50 plus 5, that is 55. Okay, acceptable. So let us check k equal to 8 also. 8 square becomes 64. So 64 times 2 gives us 128, that is already greater than 100, right? So we cannot take this value. So let us check k equal to 7. So k equal to 7 gives us, this becomes 49 times 2 plus this becomes 7, right? So this is also greater than 100. So that value is not possible. So k equal to 6, if we take, this is inside this range, right? 11 less than equal to n less than equal to 100. So the possible values of n will be at k equal to 3, 4, 5 and 6. Okay, So at these values we take the n values. So n equal to, in this case, at k equal to 3 it becomes 21, at k equal to 4 it becomes 16 times 2, so 32 plus 4, okay, 36. Then it becomes 5 square, so 50 plus 5, so 55, and this becomes 72 plus 6, so 78, okay. So summation n will be what? Summation n will be, this will be 190, okay. So what will be our correct option in this case? Option C will be our correct option, okay. Okay, the next question is saying if a polynomial function f satisfies the relation log fx base 2 equal to log of this thing times log with base 3 of this thing, and f of 10 equal to 1001, then the value of f of 20 is what? Okay, so we first have to solve this given equation, okay. So we simplify this first. Log of fx with base 2 is equal to log of this thing. So this thing is what? This thing is a infinite GP, right? This is 2 plus 2 by 3 plus 2 by 3 square plus so on, okay. So this becomes simply 2 divided by 1 minus 1 by 3. So 2 by 2 by 3. So this becomes 3, okay. So 3 then into log of this thing 1 plus fx divided by f of 1 by x with base 3, right? Now we can say by the property of logarithm that this thing will become simply log of this thing 1 plus fx divided by f of 1 by x with base 2, okay. So as the base of both side is same, we can directly compare the argument here. So this becomes fx equal to 1 plus fx divided by f of 1 by x, okay. So if we simplify this, we get fx times f of 1 by x equal to fx plus f of 1 by x. Now take a note of this functional equation, okay. This is a very important functional equation. You will get various questions have been asked in previous year JEE mains also based on this direct functional equation. We have to note the solution of this functional equation if f is a polynomial function. Remember, we are saying f is a polynomial function, okay. We also have some other functional solutions if f is not a polynomial function, okay. But in this case, we have, if this f is a polynomial, f must be of the form fx equal to 1 plus minus x to the power n, okay. This is very important. You should note down. Now if you want to get the derivation of this, you can consider this thing, okay. So if we look into this functional equation, we can say this is of the form ab equal to a plus b, right? And this thing we can arrange in this form ab minus a minus b equal to 0, right? And this thing we can also arrange by adding a 1 in both sides, okay. So ab plus 1 minus a minus b equal to 1. Now this b minus 1 we can take from this equation common from the LHS, okay. So we get b minus 1 times this becomes a minus 1, okay, equal to 1. Now a and b are what? A is fx, right? B is f of 1 by x. So we get the equation fx minus 1 times f of 1 by x minus 1. This is equal to 1. Now this thing here is what? If we consider this thing as some other polynomial function which is gx, this is what? This is nothing but g of 1 by x, right? So gx times g of 1 by x equal to 1, right? So if we have a polynomial function gx which satisfies gx equal to 1 by g of 1 by x, that means what? That means the polynomial which is of degree n must look something like this, okay. Some constant times x to the power n, right? And if we satisfy this condition, we get a square equal to 1. That means a equal to plus minus 1, right? So gx must be of the form plus minus x to the power n, okay. and fx will be 1 plus minus x to the power n. So this is the outline of the derivation. Okay, you can directly remember the result. So if we jump to the question here, we get fx equal to 1 plus minus x to the power n, right? So then we have to find the value of n by using the given information. Okay, so given f of 10 equal to 1001, that means 1 plus minus x to the power n equal to 1001. That means plus minus x to the power n is equal to, so at x equal to 10 we are talking, so this becomes 10, right? So this becomes plus minus 10 to the power n is 1000. Now we can easily see by this equation that we have to take the positive sign here, right? And then we have to take n equal to 3. So our fx is what? Fx equal to, this becomes 1 plus x cube. Okay, so the value of f of 20 will be what? F of 20 will be 1 plus 20 cube. So 1 plus 8000. So 8000 plus 1 is 8001. Okay, so the correct option here will be option number C. So this is the important functional equation you should note down. Okay, so the next problem here we have, let a and b are positive real numbers, okay, such that a minus b equal to 10 and the smallest value of the constant k for which this function is less than k for all x greater than 0. Okay, so we have this function fx equal to under root x square plus ax minus under root x square plus bx, right? This is less than k for all x greater than 0. Okay, so basically we have to find the maximum value of this function, right? So let us check the derivative of this function f dash x. The function is defined everywhere, right? For all x greater than 0, this function is defined. The derivative becomes 1 by 2 under root x square plus ax times 2x plus a, right? Minus 1 divided by 2 under root x square plus bx times 2x plus b. So if we check the sign of f dash x, we get that if we check, let's say f dash x is positive, okay, so we get 2x plus a divided by 2 under root x square plus ax is greater than 2x plus b divided by 2 under root x square plus bx, right? We can directly square both sides as both of these terms are positive, right? X is positive and a and b are positive and the square roots are always positive, right? So we can square both sides, we don't have any problem. So we can cancel this 4 here. Okay, so this becomes 2x plus a whole square divided by x square plus ax is greater than 2x plus b whole square divided by x square plus bx. Okay, so if we simplify this, 4x square plus a square plus 4ax divided by x square plus ax greater than 4x square plus b square plus 4bx divided by x square plus bx. Okay, now this thing we can say, if x not equal to 0, we are excluding the point x equal to 0, so we can cancel this x square plus ax, right? So this becomes 4 plus a square divided by x square plus ax should be greater than 4 plus b square divided by x square plus bx. That means a square x square plus a square bx must be greater than b square x square plus a b square x. Okay, so we get a square minus b square x square plus ab times a minus b times x is positive. Okay, now see this thing, a square minus b square is what? A minus b is positive, right? So a minus b times a plus b will also be positive, right? So this term is positive, x squared is positive, so this is positive. AB is positive, right? A is positive as well as b is positive, so AB is positive. A minus b is positive, x is positive, so this term is also positive, right? So this inequality is valid for all x greater than 0, right? So for all x greater than 0, this f dash x must be positive. That means f should be increasing. Okay. So the final value at x tending to infinity will be our maximum value at which the f function is tending to. Okay. So if we check for x tending to infinity, this fx tends to, if we check this, we have to calculate the limit as x tend to infinity. Okay. So limit x tending to infinity under root x square plus ax minus under root x square plus bx. So this thing we can find by substituting t equal to 1 by x. Okay. So limit t tending to 0 plus, this becomes under root 1 by t square plus a by t plus under root 1 by t square plus b by t. Okay. So this thing becomes 1 by t, then under root 1 plus at plus under root, sorry, minus under root 1 plus bt. Okay. This thing as limit t tending to 0 plus, we can write this as 1 by t, then 1 plus at by 2, right? 1 plus at by 2 minus same thing here. So this becomes a minus b by 2, right? And this is given to be equal to 5 because a minus b is 10. So this limit is equal to 5, right? That means the function tends to 5, but it does not achieve y equal to 5. Okay. So what will be the smallest value of the constant k for which this function is less than k for all x greater than 0? The answer will be option D. Okay. So option D will be our correct option. Okay. The next question is saying the sum of all possible solutions of the equation, this modulus of x plus 2 modulus minus 3 is equal to signum of this scary expression. Okay. Is equal to what? Okay. So let us first decode this scary expression here. Okay. This thing 1 minus mod of x minus 2 times x square plus 10x plus 24 divided by x square plus 1 times x plus 4 times x square plus 4x minus 12. Okay. Now to solve this equation, we must first take care of the domain of the equation. Okay. Means for which values of x the function is defined. So we must have this denominators of these functions as non-zero, right? So we must have x not equal to minus 4, x square plus 4x minus 12 not equal to 0. That means if we try to factor this, this becomes x minus will be 6, no, x plus 6, x minus 2, right? This is non-zero. That means x not equal to 2, x not equal to minus 6. Okay. And then if we try to similarly factor this expressions here, this expression is factorizable, right? Easily we can factorize this. This becomes x plus 6 times x plus 4. Now see, as we are excluding the points x equal to minus 4, x equal to minus 6, x equal to 2, we can actually cancel these factors, right? X equal to 2 is not in domain, so we can cancel this x minus 2 with this x minus 2 here. Okay. So x minus 2 gets cancelled, then x plus 6 gets cancelled, x plus 4 also gets cancelled. Okay. So what we are left with is this expression 1 minus mod of 1 divided by x square plus 1, right? Now this thing is simply 1 minus 1 divided by x square plus 1. Why? Because mod of this thing is simply this thing itself, right? This thing is always positive. So this becomes x square divided by x square plus 1. Now see, we are trying to find its signum, right? So this term is always positive except for x equal to 0, right? At x equal to 0, this quantity becomes 0. So signum of this thing, signum of this will become 0 if x equal to 0, and it will become 1 if x not equal to 0. Okay, so we have to analyze both the cases. So if we take case 1, x equal to 0, so if x equal to 0, we can verify whether this equation is satisfied or not. Let us check. So this LHS becomes 2 minus 3 mod, so 1 equal to, the right hand side becomes simply 0, right? This is not true. So x equal to 0 is not going to be a solution of this equation. Okay, case 2, if we take x not equal to 0, so we get right hand side equal to 1, right? And the left hand side becomes mod of x plus 2 minus 3, then modulus again. Okay, so if we try to solve this, we get x plus 2 modulus minus 3 is equal to plus minus 1. So mod of x plus 2 equal to 3 plus minus 1, so 2 or 4. Okay, that means x plus 2 equal to plus minus 2 or plus minus 4, or we can say x equal to 2 minus 2, so 0, then minus 2 minus 2, so minus 4, plus 4 minus 2, so 2, minus 4 minus 2, so minus 6. Okay, now see, none of these solutions is possible. Why? Because x equal to 0 is not a solution of this equation. We already tested it. X equal to minus 4 will not be a solution because it is not in the domain of the function, domain of the equation. Okay, we have excluded the points x equal to minus 4, x equal to 2, x equal to minus 6, right? That means what? The solution of the equation does not exist. So our solution is simply this null set. Okay, so sum of all possible solutions will be what? It is not applicable, right? We don't have any possible candidates which we can sum up, right? So the set is empty, so sum of all possible solutions is not applicable. Okay, let us jump to the next problem. Okay, if x equal to sine to the power 23 x minus cos to the power 22 x, right? And gx equal to 1 plus half times tan inverse mod x, then the number of values of x in interval this satisfying the equation fx equal to signum of gx is what? Okay, so let us try to find the signum of this function first. Gx, we can say this mod x will be always positive or equal to 0, right? So tan inverse, if we pass some positive parameter in the tan inverse function, it will return some value which is greater than equal to 0 and less than pi by 2, right? So we must have this tan inverse mod x belonging to the interval close 0 to open pi by 2, right? So we can say clearly this gx is positive, right, for all x. So what will be signum gx? Signum gx is 1, right? Signum of this function is equal to 1 for all x. Okay, then we have to find the solutions of the equation fx equal to 1. Okay, so let us find sine to the power 23x minus cos to the power 22x equal to 1. That means we can rearrange this as sine to the power 23x equal to 1 plus cos to the power 22x. Okay, now we can see a very interesting thing here. The right hand side of this equation is belonging to the interval 1 to 2, right? Because this thing is positive, right? So positive or equal to 0, that means close 0 to closed 1. And if we add this 1 here, we get closed 1 to closed 2, right? But the left hand side belongs to the interval minus 1 to 1, close minus 1 to closed 1, right? So the only case when both sides are equal is when both the sides equals 1. Okay, so we must have LHS equal to 1 as well as RHS equal to 1. Okay, so that means sine x should be 1, right? And cos x should be equal to 0. So if we try to find the solutions of these two simultaneous equations in minus 10 pi to 20 pi, we can first find the solutions in 0 to 2 pi and then multiply the number of solutions by 15, right? Because in minus 10 pi to 20 pi we have total 15 periods covered of these two functions, right? Sin x and cos x are periodic with period 2 pi. So if we have, let's say, n solutions in 0 to 2 pi, we must have 15 times n. So 15 n solutions in minus 10 pi to 20 pi. Okay. So in close 0 to 2 pi, if we observe, sin x looks like this, right? Cos x looks like this. So what will be the solution here? So this is cos x. Okay. So we can see only one possible solution, right? At this point, sin x equals 1. So this is x equal to pi by 2. This is cos x equal to 0. So x equal to pi by 2. Okay. So we have one solutions in close 0 to 2 pi. That means we have how many solutions of this equation in this interval? We have total 15 times 1, which is 15 solutions. Okay. So option C will be our correct option. Now this question is saying the function f defined from R to R defined as fx equal to half log of this expression is what? Okay. So we have to check whether this function is 1 1 or on 2. Okay. Let us check. So by looking into this expression given in the question, we can say by pure observation that fx equal to f of minus x, right? Why? Because let's say I interchange x with minus x throughout the expression. Okay. Then the expression remains unchanged. That means f of minus x equal to fx. Okay. So we can say fx is an even function, right? We know for an even function, there are two values of x corresponding to a single y value, right? Let's say at x equal to 2, there is some value f2. Then at x equal to minus 2, we will also have the same value f of 2. Okay. That means this function is not 1 1. That means this function is many one. Okay. Now let us check the onto nature of this function. So to check the onto nature of this function, we have to first find its range, right? Now think about this. If I, let's say, take this expression here, root under, then again root under x square plus 1 plus x to be some t. Okay. So this is some t. What will be this expression? What will be this expression? Okay. This expression will be simply 1 by t. How? Because let's say we calculate 1 by t. So this becomes 1 by under root x square plus 1 plus x, right? So this becomes under root 1 divided by root under x square plus 1 plus x. And this thing is clearly root under x square plus 1 minus x, right? We have already talked about this in many sessions that this is a very famous type of expression where the reciprocals are differing by a single negative sign. Okay. So this thing becomes equal to this thing. Okay. So what we have inside this log function? We have t plus 1 by t, right? And by AMGM inequality, we can say this is greater than equal to 2, right? For all t, for all real positive t. And this t is, of course, positive, right? This is some square root. So square root function will always return some positive value. So we must have this greater than equal to 2. That means this half log of t plus 1 by t will belong to the interval half log 2 to infinity, right? That means f must belong to the interval closed half log 2 to open infinity, right? Now this set, this half log 2 to infinity is certainly not equal to the set of all real numbers, and codomain is not equal to the range. Okay, so this function should be into. So what will be our correct option here? In this case, correct option will be neither 1 1 nor on 2. Okay, let's jump to the next problem. Okay, let fx equal to mod of x minus 2 and gx equal to this composite function. Okay, we take the composition of f n times. Okay, if the equation gx equal to k belongs to open 0 to 2 has 8 distinct solutions, then the value of n is equal to what? Okay, so first of all, let us plot the graph of fx. Okay, the graph of fx will look something like this. At x equal to 2, we have two lines. Okay, So this is the graph of mod of x minus 2. Now how to draw the graph of f of fx? This will be simply mod of fx minus 2, right? So this becomes mod of x minus 2 minus 2. Now how to draw its graph? We can simply use the idea of graphical transformation. So this point is what? This point is 2 comma 0, right? So this is the graph of mod of x minus 2, this part, okay? So to get the graph of mod of x minus 2, we need to shift this graph of mod of x minus 2 2 units downward, okay, in the negative y direction. So this graph looks like this after transforming, okay. Then we have to take the modulus all over this expression, right? So that means we have to remove the negative part of this graph of mod of x minus 2 and then take the reflection of this removed part about x-axis. So we remove this part, okay. We remove this part here and take the image of this part about x-axis. So the image will look something like this, okay. So this becomes, if we redraw, like this, okay. This point is what? This point is directly above x equal to 2. So this point becomes 2 comma 2, okay. Now see, if we have n equal to 2, okay. So in this case n equal to 2, we are talking about n equal to 2, okay. For n equal to 2, if we draw a line y equal to k, so y equal to k means this line some constant and k belongs to open 0 to open 2, right? We can see easily that this line y equal to k cuts the graph of this f of fx. This is the graph of f of fx, okay. This straight line cuts this graph at 4 places, okay. So there are 4 solutions of this equation, this f of fx equal to k, right? Similarly, if we try to plot n equal to 3, n equal to 4, n equal to 5, so on, we can see a pattern. We can see a pattern that if we have say f of so on up to this, so we are taking the composition n times, okay. If we take the composition n times and then we have this as gx, okay, then the line y equal to k will cut this gx, y equal to gx exactly 2n times if k belongs to 0 to 2, okay. That means if we have 8 distinct solutions, we must have 2n equal to 8, right? That means n equal to 4. So what will be our correct option here? Option B will be our correct option, okay. Next we have a paragraph question and we have 3 questions based on this paragraph, okay. Let us solve this first paragraph. What is this saying? An even periodic function. So this function is even, okay, very important. Even periodic, okay, with period 4, okay, is such that fx equal to maximum of these two functions when x is lying in this range closed 0 to open 1, and fx equal to the identity function when 1 less than equal to x less than equal to 2, okay. So we are given the definition of fx in close 0 to close 2, right? So let us try to plot this function first. So we attack this problem graphically. Let's say this is our graph, this is y, this is x, okay. This is x equal to 0, this is 1, this is 2. So let us try to plot the graph first. Fx is maximum of mod x and x square, okay. So y equal to x square will look something like this if we try to plot it in 0 to 1, right? Like this point will be what? This point will be 1 comma 1, right? And mod x will be this, right? this is mod x, this is x square. Okay, so we can clearly see which function is maximum in this close 0 to open 1. Okay, so we are excluding this point 1 comma 1. Okay, so we are excluding, so at this point we don't have any functional value yet. So we can clearly see which function is maximum, or the function whose graph is above the other function. Okay, so the graph of y equal to mod x is clearly above this function y equal to x square, right? This is y equal to x square. So we can clearly see this fx equal to mod x when 0 less than equal to x less than 1. Okay, now if we discuss the case 1 less than equal to x less than 2, this graph is simply y equal to x, right? That means this will continue. This graph we have the previous graph y equal to mod x, this is simply the line y equal to x, right? Because in case of a positive x we must have mod x equal to x. So this graph will be continued till x equal to 2, right? So closed at x equal to 2. So we have the graph of y equal to fx in 0 to 2. We have the graph something like this. Okay, this is 2, this is 1, this is 0. The graph looks like this. This point is what? This point is 2 comma 2. So this becomes x for 1 less than equal to x less than equal to 2. Now the question is, we are given the definition of fx for 0 to 2 only, right? But we are told that the period of this function is 4, and we are only provided the definition of this function in 0 to 2. Then how can we find the definition for the whole period? Because if we want to find the function completely, we need to find the definition of this function for at least one period, right? So that we can replicate the functional values all over the real line. Okay, but remember, we are given some specific information about this function. What is that? The information is this thing. Okay, the function is even. Now this function is even, that means this function is symmetric about y-axis, right? Because we know for an even function we can write fx equal to f of minus x, right? That means if we take the mirror image of this function from 0 to 2 about the y-axis, we will get the definition of this function from minus 2 to 0. Okay, so if we take the mirror image, we get something like this, right? So this point becomes x equal to minus 2. So we have something like this. Okay, so we can clearly see this is the total period of this function from x equal to minus 2 to x equal to 2. This is the period 4. Okay, so we have to replicate this pattern throughout the domain, which is all the real numbers. Okay, if we want to draw a graph of this function, we can draw this easily. The function looks like this. So it is minus 2 to 2, then it becomes same. Okay, same goes for negative side also. So this patterns continue till infinity. Okay, and this maximum value which f can take here is simply, we can say 2 here, right? So let us answer these questions. The value of fractional part of fx at x equal to 5.12. Okay, so x equal to 5.2, sorry 5.12. If we try to plot, this is the point x equal to 2, right? This is the point 2 plus 4, that is x equal to 6. So x equal to 5.12 will be somewhere here, let's say like this. Okay, so at x equal to 5.12, we have to take the fractional part of this functional value. Okay, and this point is what? This point is the midpoint of this x equal to 2 and x equal to 6. This point is x equal to 4, right? So let us try to find the equation of this straight line. The equation of this straight line is y equal to x minus 4, right? So what will be the value of fx? Fx at x equal to 5.12, it will be simply 5.12 minus 4, that is 1.12. Okay, so what will be its fractional part? It will be simply 0.12. Then if we try to check here, let us check the options also. F of 7.88, this fractional part, so 7.88 x equal to 8 is here, right? This is x equal to 8, as this is x equal to 4. This is just a period apart, right? So the gap of them must be equal to 4, so we have this point as x equal to 8. So we have this, let's say, as x equal to 7.88. So at x equal to 7.88, we must have y equal to 8 minus x, right? So f of 7.88 becomes 8 minus 7.88, that is 0.12, and its fractional part will be itself, right? This is also 0.12. Okay, so we can see we got our answer in the first option itself, so our option A will be correct option. Let us solve the fourth question here, the second question of this paragraph, that means the question number 4 here. The equation of circle with center lies on the curve fx at x equal to 9 and touches x-axis. Okay, so if we try to find x equal to 9 here, we can say this graph, this pattern will continue, right? This is the point x equal to 6, so this point will be x equal to 10, right? So x equal to 9 will be the midpoint of this. So the equation of the circle with center lies on the curve fx at x equal to 9 and touches x-axis. That means the circle must look something like this. Okay, the center of this circle must be 9 comma f of 9, and the radius will be f of 9. Okay, so what will be the equation of this straight line? The equation of this straight line from x equal to 8 to x equal to 10 will be simply y equal to 8, sorry, x minus 8, right? So if we try to find the functional value here, f of 9 will be simply 9 minus 8, which is 1, right? So the radius of this circle is 1 and the center is at 9 comma 1. Let us check the options here. So we must have the center at 9 comma 1 and radius equal to 1. That means only one option is satisfying this condition. Okay, so option C will be our correct option. Let us solve the next question. If gx equal to mod of 3 sin x, then the number of solutions of fx equal to gx for x belonging to open minus 6 to 6 are what? Okay, so if we try to draw the graph of gx first. So first of all, we need to draw the graph of sin x, right? Sin x looks something like this. This is from 0 to 2 pi, and this is from minus 2 pi to 0. And minus 6 to 6 will be inside this range, right? Let's say up to this point. So this interval we are talking about. Okay, this is minus 6, this is 6. So we first draw the graph of 3 sin x. Okay, as we know, sin x varies from minus 1 to 1, right? This is minus 1, this is 1. So 3 sin x will vary from minus 3 to 3. Okay, so the graph will be changed to this graph. Okay, the graph will be elongated along the y-axis. So the graph will look something like this. Like this. Okay, so this point, so this point becomes minus 3 and this point becomes 3. Okay, 0 comma 3 and 0 comma minus 3. Then we have to transform this graph to mod of 3 sin x. Okay, so we do the same thing here also, that we remove the negative part of this graph and reflect this negative part about x-axis. Okay, so the graph will look something like this. Okay, let us draw this. So the graph will look something like this, and this height is equal to 3. Okay, this height is equal to 3. This is the point 0 comma 3, this point. Okay, so we have to find the number of solutions of gx equal to fx, right? So this is the point x equal to minus 6, so this will be minus 2 pi, so we have to take this point somewhere here. Let's say here. Okay, this is x equal to minus 6, this is x equal to 6. So then we superpose the graph of fx on this graph. Okay, so the graph of this function will look something like this. Okay, and this side we have the mirror image of this, so this function becomes like this. Okay, this is the point x equal to 2, this is the point x equal to minus 2, right? This is the point x equal to 4, this is the point x equal to minus 4, and clearly we have a intersection point here, right? Let us use another color here. So this is an intersection point, and this is another intersection point, this is another intersection point. Okay, so we have total 3 intersection point here, and this side we also have 3 intersection points. So here we have 3, here we have 3, but at x equal to 0 both functions are equal, right? So we have another intersection point here. So what will be the total number of solutions of this equation if x equal to gx? Total number of solutions will be 7. Okay, so what will be our correct option? Correct option will be option number B. This is the last question of this session. Let us solve this, the last paragraph. Okay, so this says let fx equal to this function and gx equal to this function. Okay, so fx and gx are piecewise defined. Okay, the function g of fx is not defined if alpha belongs to this, if beta belongs to this. Okay, so we have to find the range of alpha and beta such that g of fx is not defined. Okay, so let us solve this. So first of all, we need to understand when g of fx is not defined. Okay, so we know for g of fx to be defined, we have to have this fx lying in the domain of gx. Okay, and the domain of gx is what? If we look into this definition, we can say domain of gx is simply minus infinity to 8, right? That means if fx is greater than 8, g of fx will not be defined, right? So let us take this case, fx greater than 8. So let us first understand this fx. Okay, so fx is beta x square plus 3 when minus infinity less than x less than minus 1, right? So let us try to draw the graph of this function fx. Okay, so from minus infinity to minus 1, the function is beta x square plus 3. That is, if we try to find the value at x equal to minus 1, this becomes beta plus 3, right? So this function is tending towards beta plus 3 here from the left hand side. Okay, and then after x equal to minus 1, we have this line 2x plus alpha, right? So 2x plus alpha, at x equal to minus 1, it will be alpha minus 2, right? So let us take this function to be like this. Okay, it is a straight line with positive slope, right? So that means we have to have this fx outside the domain of gx. That means we can say what will be the minimum value of fx in this case, or in both sides of x equal to minus 1. On the left side we have the minimum value at x tending to minus 1, right? So this becomes beta plus 3, right? And in the right hand side of this x equal to minus 1, we have minimum equal to alpha minus 2, right? So we must have beta plus 3 must be greater than 8, right? And alpha minus 2 must be greater than 8. Okay, so that means we get, by solving these two conditions, that beta should belong to 5 to infinity, right? And alpha should belong to 10 to infinity. Okay, so that means which option is correct here? Option A will be correct here. Okay, in this case fx lies outside the domain of gx, right? So g of fx will not be defined. Let us solve the next question. If alpha equal to 2 and beta equal to 3, then range of g of fx is equal to what? So let us write fx first. Okay, for this alpha and beta values, fx is 3x square plus 3 when minus infinity less than x less than minus 1, and it is 2x plus 2 when x is greater than equal to minus 1, right? So let us check the range of this fx function first. Range of fx will be what? Range of fx, on the left side of x equal to minus 1, we have the range as beta plus 3 open to open infinity, right? So left side we have the range beta plus 3, so beta is 3, right? So 6 to infinity with open bracket at 6, right? And right side we have the range alpha minus 2, so close 0 to open infinity, right? That means if we take the union of these two cases, we get the range of this function, right? So we get the range of f as close 0 to infinity. Okay, so this we are talking about the ninth question here, and this was the situation for eighth question. Okay, so that means this fx is belonging to close 0 to open infinity. Then let us work on the definition of gx here. So gx is what? Gx is x plus 4 if 0 less than equal to x less than equal to 8, and it is equal to minus 3x minus 2 if x is less than 0. Okay, so as we are working with this branch of gx equal to x plus 4, as we are saying that if x is lying in close 0 to open infinity, we have to consider this definition of gx, right? Gx equal to x plus 4. That means what will be g of fx? G of fx will be simply fx plus 4. Okay, so that means if we try to find the minimum and maximum values of this g of fx in this interval, fx belonging to closed 0 to closed 8, right? Because the domain of the function gx is defined as minus infinity to closed 8, right? So we must have this fx belonging to closed 0 to closed 8, right? So this is simply a linear function in fx, right? So this function g of fx will vary from, we can say, 4 to 12. Okay, so what will be our correct option here? Correct option in this case will be option number C. Now let us solve this last question of this session. If alpha equal to 3, then the value of x in the interval 1 to 3 for which fx plus gx equal to 12 is what? Okay, so if alpha equal to 3 and x is lying in close 1 to close 3, then what will be fx and gx? Fx, we can say this will be 2x plus alpha, right? Because this definition of fx is valid for minus 1 less than equal to x less than infinity, right? So we have to use this definition of fx, and for gx we have to use this definition of gx, right? Because we are taking x belonging to closed 1 to 3, so we have to take this definition. Okay, that means what will be fx and gx? Fx and gx will be simply 2x plus alpha and x plus 4. Okay, so that means 2x plus 4 plus x plus alpha should be equal to 12. That means alpha is equal to 3, right? So we get from this equation 3x equal to 5, right? So x is equal to 5 by 3. That means which one will be correct option? Option C will be our correct option. Okay, so that is how we solve this question based on composite functions. Okay, so that's all for today, guys. I hope you enjoyed the session. Although the session was too lengthy, I understand. From next session onwards, I will try to take the questions section wise. Okay. So multiple correct questions in a separate video, and then integer type questions in a separate video, matching list type in a separate video, etc. Okay. So that we can solve more questions in a short time period. If you are new to our channel, subscribe to our channel for more JEE related content and share this video with your friends and fellow aspirants. Okay. Thanks for watching.